So I've gone ahead and downloaded 4 images over the Ottawa region, and you can see here that I have 4 folders. So 2 of the images were collected along the same track on April 21st, and 2 of the images were collected on April 28th. So these are 7 days apart. So hopefully there isn't too much in terms of variation on foliage and so on. But as you'll see, at this time of year in Ottawa, we actually had quite a bit of snow and ice still on the ground. We had a very late winter this year, and you'll see on this imagery that there are actually quite some differences in addition to some clouds. Now each one of these images, as you can see, has multiple bands. So each one of these bands represents the different spectral information which is contained in the data set. And band number 8 is the panchromatic band. You'll notice there the file size is significantly larger in addition to the dimensions. The thermal bands are also included in the full download. And in order to load the data into Focus, PCI Geomatica's viewer, it's very straightforward. So every Landsat-8 image is distributed with this metadata file. This is an ASCII file, and so we can get all of the information relating to the image. So PCI Focus, PCI Geomatica will simply load this data automatically. So if I drag and drop the metadata file onto Focus, I'm given a selection tool. So I can select to load the panchromatic, the multispectral, the thermal, or the quality band. So I'm going to load the panchromatic. So here's the panchromatic image. And similarly, I can just drag and drop that again. And this time I'll select the multispectral bands. So now I have both the multispectral bands as well as the panchromatic bands. At this point, the images are separate, so the multispectral information is available at 30 meter resolution. However, I'd like to take advantage of the 15 meter higher resolution data set in the panchromatic band and carry over the multispectral information, and that's done through Pansharpening. Pansharpening is very straightforward. I'm simply going to go to Tools, Algorithm Librarian, and I'll click on Find, type Pansharp, find the algorithm. So if I open up Pansharpening algorithm, I will essentially have to provide a few input parameters. So the multispectral image channels, the panchromatic image channels, and then decide where I want to output this file. So the input channels in the case of Landsat-8 are 4, 3, 2 if we're trying to create a natural color composite. And the input panchromatic channel has been already detected here. It's band number 8. And then I specify where I would like to place this file and just essentially run it. So I've run that Pansharpen process, and now you can see that I have a multispectral 15 meter resolution data set. So if I zoom out to the full extent here and go back into an area of interest, so this is downtown Montreal. I'll go in at 1:1 resolution. So you can get a sense that this is what the Landsat data looks like when it's been Pansharpened to 15 meters. So as I mentioned off the top, the problem often with Landsat imagery is that your area of interest is at the intersection of the different tiles. The Ottawa region is roughly in here, and you can see that if if I want to make a seamless image of my area of interest, I'm going to have to mosaic the different images together, and in order to get a nice looking data set. So the next step in this demo is to create a seamless mosaic from the 4 different Landsat images in order to get a seamless image of our central area of interest, the city of Ottawa and the surrounding area. We're going to be doing that with Ortho engine. I've got a project already set up with the images. And the first step would be to determine the projection. So I've got my projection and the resolution. So the images that I'm using for this mosaic are the pan-sharpened images. So there are 4 pan-sharpened images that I'm going to mosaic together into one seamless image. This is the data input step. So I've already added the 4 images to my project. So you can see the 2 images from April 21st and the 2 images from April 28th. And I can have a look at the layout of those images. Here's the image centers and the footprints. And the next step will be the actual mosaicing. So the mosaicing tool is automated, and the cut lines are generated automatically as well. So I can select automatic mosaicing, and our images are loaded in to the mosaicing step here. And we can choose to have a look at the cut lines before we commit to generating the mosaic. So if we click on Generate Preview, we can get an update. We can get a view of the mosaic. So here we have the automated cut line generation results. And we can get a sense of how the image is going to look like, the final mosaic is going to look like. And if we want to, we can modify these cut lines. For example, these cloud areas here, there might be a little bit of a very obvious discontinuity if I don't move this cut line. So I might move this cut line away to preserve this part of the image, just to make it look smoother. And once I'm happy with that, I would basically hit Generate Mosaic. And it does take a little bit of time. It's churning through quite a bit of data here. So here's the final result mosaic. So as you can see, we have a very smooth looking complete image composed of these 4 different Landsat images. And if I wanted to clip out an area of interest that encompassed Ottawa, I would be able to do that in a much more simple way from this mosaic, as opposed to having to work with the 4 separate images. As compared to the mosaic, this is the situation I had before. So as you can see, this yields very nice results, and very straightforward to accomplish using PCI Geomatic software. Thanks for listening to this PCI tutorial. If you'd like to keep track of new videos that appear on our channel, please subscribe, and we hope to see you soon.